Welcome students. In this video series, we are seeing subject data structure and we have reached up to the last chapter, that is trees and graph. Now what happens exactly? Earlier we have seen stack, queue and linked list. These three type of data structure were linear data structure. Linear data structure, as you are aware, the numbers or the given data will have a linear relationship in that. That means one data is followed by another data. Sometimes in real life there exists a data which is not in a linear form. That data is called as non-linear data. For example, if you want to display all the tourist places in India, then that kind of structure will be like a tree or a hierarchical data structure, which is not a linear. Hence, it is called as a non-linear data. Another example of non-linear data is map of cities. Suppose you want to go from one city to another city and from that another city to another city and come back to the original city. Now this diagram is like a graph. Hence it is called as a graph. So tree and graph are two different types of non-linear data structure. So this is the last part of the syllabus. So we will see how it works. First of all, we will see introduction to trees. A tree is defined as finite set of one or more nodes. So there will be nodes in the tree. See the diagram. This A is called as node, B is called as node. So these are nodes. So there can be only one node in a tree because the definition says one or more, right? So it means that there can be only one node in a tree. So this is also an example of tree. So what is tree? Tree is defined as finite set of one or more nodes. There is a node designated as the root of the tree. So in your tree there will be one node which is designated. Which is designated means it is named as, it is termed as the root of the tree, right? For example, in this diagram, A is the root of the tree. Other nodes are the children of the root nodes. In this diagram, these nodes are children of root A. So this is the definition of a tree. I will repeat once again. A tree is defined as a finite set of one or more nodes. There is a node designated as the root of the tree and other nodes are the children of the root tree. A tree is a non-linear data structure which we have already discussed. Trees are mainly used to represent data containing a hierarchical relationship between elements. This we have already discussed. Now here each line connecting two nodes is called as a parent-child relation. Generally it is a convention to draw root node at the top and let the tree grows downwards. In real life the tree grows upwards, but in data structure the tree will grow downwards and root will be at the top. After that, these are the different questions which were asked in your exam. Definition and terminologies of trees. Define the terms related to binary tree like level, depth, leaf node, root node. So there are different terms related to trees and binary tree is a type of tree. So next topic will be tree terminologies and after that types of trees. And based on those topic, these are the questions which were asked in your exam. So let us see tree terminologies. Terminologies means basic definitions of trees. Some points in the trees. First is the definition of tree, which we have seen just now. After that, degree of a node. So degree of a node is equal to number of children that node has. For example, if you see D, if you see this much part, then for this D is the root and it has only one child. Hence the degree of this particular node is 1. Then if you see this part, then you will observe that B is the root of this part and only it has two children, D and E. H is the child of D. It is not the child of B. You can say that H is grandchild of B. But degree of a node depends on number of children that a node has, means direct connection from B to other nodes. There are only two direct connection from B to other nodes downwards, right? There is one more direct connection from B to A, but this connection is upwards. That means A is the father of B and B is the child of A. Or you can say that A is the root of B and B is child of A. In the same way, D and E are children of root B. Degree of a tree. The maximum degree of a node in the tree is known as degree of a tree. The maximum degree of a node here in this diagram, the maximum degree of any node is 2 because each root is having only two children. Therefore, in this case, the degree of the tree is 2. Then, level of a node. Level is the rank of the hierarchy. Every node in the binary tree is assigned a level number. The root is defined at level 0. This is level 0. Then this is level 1. Then this is level 2. And this is level 3. So in this figure 6.2, that is this figure, B and C nodes are at level 1. D, E, F, G nodes are at level 2 and H and I nodes are at level 3. So level is the rank of the hierarchy. Every node in the binary tree is assigned a level number. The root is defined at the level 0. So we have seen tree, we have seen degree of a node, degree of a tree and level of a node. Now we will move further. Now we will see leaf node. A node that has no children is called as a leaf node or terminal node. See the diagram. A node which has no children. In this case, H is having no child. E is having no child. F is having no child. I is also having no child. So these nodes are called as leaf node. The next topic is depth or height of a tree. The length of the path from the root node to the deepest node in the tree is known as height of the tree. A tree with only a root node has height of 0. In the figure 6.2, the height of tree is 4. So what is the height or depth of a tree? It is the length. Sometimes it is also called as height, sometimes it is also called as depth, which is nothing but the length. Length of what? Length of path from the root node, from the root node to the deepest node in the tree, to the deepest node in the tree. So let us see what is the deepest node in the tree. See here. This is 1, 2, 3, 4. H is the deepest node in the tree. So you just count a path from A to H. That is 1, 2, 3, 4. Hence the height of the tree is 4. Then we will see in degree of a node. Now in degree of a node is the number of edges arriving at that node is known as in degree of a node. For example, the in degree of B is 1. The number of node arriving at B, right? So B arriving, right? These two are leaving. I will show you diagrammatically. The number of nodes arriving. This is called as arriving. We will see always see from top to down. This arrow, if I draw like this is outgoing, right? This is not arriving. Okay, right? So how many nodes are arriving? Only one node is arriving to B. And how many nodes are arriving to C? Only one node is arriving to C. So this is about the in degree of a node. Out degree, this is opposite of earlier. The number of edges leaving that node is known as out degree of a node. For example, how many nodes are leaving from B? 2, right? How many edges are leaving? 1 edge, 2 edge. So the out degree of B is 1. How many edges are leaving from C? This is 1 edge and this is 2 edge. So the out degree of C is also 2, right? Out degree of B is also 2. Out degree of D is 1. Out degree of E is 0. F 0. Out degree of A is 2. What is in degree of B? In degree of B is 1 because only one edge is arriving. So this was about out degree and in degree. Now we will see directed edge. Now we will see directed edge. The line drawn from a node n to any of its successor is known as directed edge. Actually, directed edge, it is the concept of graph, but sometime in exam they asked in tree also. So if you are having an arrow from one node to another node, that arrow is called as directed edge. Diagrammatically I will show you. Now here there are no arrows. There is, because arrow is the concept of graph. This type of arrow will be there in graph, and this arrow are direct, they are showing some direction, hence they are called as a directed edge. But in exam they may ask you the same definition for tree also, so you have to write this definition. Directed edge, the line drawn from a node n to any of its successor, is known as a directed edge. Path, a sequence of consecutive edges is called as a path, right? A sequence of consecutive edges is called as path. So we will see diagrammatically what exactly a path is. The path from A to H is, the path from A to H is A, B, D and H. What is the path from A to I? A, C, G, I. So this is the definition of path. I will repeat once again. A path is a sequence of consecutive edges, right? Consecutive means what? One after another, one after another. Now, next terminologies in tree is ancestor node. Ancestor node, ancestor in Marathi, we will call it as Purvaj. The parent, the grandparent, the great grandparent of the node are called its ancestor. For example, A is the ancestor node in above diagram, right? In this diagram, A is the ancestor node, right? C is also ancestor for I, right? B is also ancestor for H, right? Now we will see descendant. Descendant means the child, the grandchild or any child down the hierarchy of a node is called as descendant. So descendant, the child, grandchild or any child node down the hierarchy of a node is called as descendant, right? For example, H is the descendant in the diagram. I will show you the diagram. It will be easy for you to understand. For example, here H is the descendant. Okay. D is also descendant of A, right? Ancestor and descendant. These are the two concepts. Now, next concept, two concepts are remaining, forest and sibling. Forest, it is very easy to understand. If there is a tree and if there are number of trees, it is called as forest. Forest is a set of several trees that are not linked to each other, right? A tree may have branches, right? That is not forest. But if there are number of trees, then it is called as forest. Siblings, siblings means children of the same parent, right? Sibling means children of the same parent. In the diagram, B and C are sibling because their parent is A, right? In this diagram, D and E are also sibling because their parent is B. In this diagram, F and G are also sibling because their parent is C, right? So these were the tree terminologies which we have learned. So in next lecture, we will see type of trees. We will see general tree, binary tree, complete binary tree, extended binary tree, and binary, search tree and expression tree, right? So these are the different types of trees in your syllabus. We will see one by one.